frame. See, all you need to do is understand what I'm saying. Well, you want to take moment about here. 1 force, 2 force, 3 forces, right? How to take moment? Oh, okay, perpendicular distance. This one, maybe you can find. True? Let's take a look at this one. This one also maybe you can find. But what about this one? Or this one also maybe you can find. Okay, these are perpendicular distances that you should know. Okay, but sometimes this kind of distance is hard to find or impossible to find if they don't give you certain angles or dimension. True? So what is a key thing that you need to know? You always resolve to the body frame. What is the body? This is the body, right? Agree? This is the body, huh? Resolve to the body frame, meaning resolve to this x and y. You will see y. All the forces resolve to x and y. Y, you see, this 50, obviously this is, what did I teach you how to get angles? I told you look for parallel lines, right? Yeah. For this force, you want to resolve to this, so-called this body frame, right? You must need at least one angle, correct? Yes. So, you will go back to the problem. They always give you values, right? Here, 50, right? So look for parallel lines. This line and this line parallel. Yes. This line and this line parallel. So this must be 50. Always follow this thing. Okay. Once you have 50, you will be able to resolve the forces immediately. This is 100 cosine 50, 100 sine 50. Agree? Yeah. So that one settled. So let's move on. Let's talk about this force. This force is given already, so very simple. This is 80 cosine 50, 80 sine 50, right? Yes. Last one, this force. So now, in order to resolve this force to the body frame, you need some angle. So look at this. Is this 40? Look at this. Is this 40, right? Yeah. This line and this line parallel? Yeah. This line and this line parallel? Yeah. So this must be 40. So you always do that. Once this known, you can resolve. What is the W? 100 Newton, right? This 100 Newton. 1,000. So it's 1,000 cosine 40, right? This one is 1,000 cosine 40. Once you have this, it's almost done. Why? Now you just have to slowly, the sum of moment of all these forces. It's a tedious process, but you just sum them up. Do you know how to sum them up? Summation moment about O. What do you have? One at a time. Take this first. This force about O, perpendicular distance here, right? Is given, right? Yeah. CO is 0.25. So this one speed 0.75. Clockwise or anti-clockwise? Anti-clockwise. So what you must find? Minus 100 sine 50 times 0.75. Right? Done. Next, this one. Go straight to O. Any moment? No. Next, this one. This is at the halfway mark. So this halfway mark means this is 0.5, this is 0.5. So this is already 0.25, so this must be 0.25. Clockwise or anti-clockwise? So you put negative 100 sine 40 times what? 0.25. Yeah? Yeah? So this one. So same, 0.5, right? Clockwise or anti-clockwise about O? Clockwise. So it's plus 100 cosine 40 times 0.5. Okay? All four down, last two. This one. This is a perpendicular distance. Clockwise or anti-clockwise? Anti-clockwise. So it's minus 80 cosine 40 times 0.25. Do you understand? This one. Take the pen, put at the pivot point, rotate to the perpendicular to the force. Let the force hit the pen. So it rotates anti-clockwise. Yeah? Yeah? So last one. This one. Yeah, it's 1. But clockwise or anti-clockwise? Anti-clockwise. So it's minus 80 sine 40. Right? Sine times what? 1. Then you have it, find answer. Easy? Easy, right? So, the key thing about this is what? What makes it easy? When you resolve the forces with a body frame. That's what makes it easy. And you must remember this. This is a trick to solve moment. Not trick, anyway, this is the method. Clear? If you are clear, then next Tuesday you should be very, very confident. So I'm going to explain how you tackle last question. If you can understand the last question and have the confidence that last question is also very easy. You know why? I'll show you why.
Theoretical.
Okay?
Theoretical 啊。
Sorry, what? Oh, okay, now, that's a good question. So read the question properly. The question says what? The resultant moment about O if the forces are applied, B and D. Okay. Let me erase everything. So, applied at B and D meaning what? Do we just take moment at B and D? Yes or no? What do you think for those who tried before? Do you only take moments of the force at B and D? Yes or no? No. No. Why? No. Why no? Why no? No. Because is this a force? It's a force. How you can never ignore this force. This is mg. How can you ignore mg? And furthermore, if you read carefully, if the forces are applied, how many types of forces are there? I taught you 3 types, right? These are external forces. This is internal force. So the question, nothing wrong, you know. Applied forces. But you cannot say, oh, only B and B. No. You should know. This is basic concept again. How can you ever ignore mg? No way, right? Do you understand the yes? Because it's already in Newton. It weighs 1,000 Newton already. Normally they'll give you kg. If it weighs 10 kg, you must times 9.1 to get Newton. Can I? Okay, now, okay. You see, the exam is very fair to you. 7 marks goes all the way to you for doing your basic thing. But you realize the 3 marks not so easy to get. Why? Because those who try, do you know how to solve? You don't know how to solve. Okay, from first part, you will realize that you get what do you call that? Anti-clockwise moment of, let's say, 90 Newton-meter. Yeah? That's what you get from part A. What does this mean? The resultant moment is 90 Newton-meter. Means this body is going to what? Rotate. Rotate, huh? Sorry, I think it's clockwise. Anyway, doesn't matter. If your answer is clockwise, means this body is going to rotate. It's going to drop. What it's saying is, what is the smallest force here? Smallest force that you should apply at A is specified clearly. What is the smallest force to be applied at A so that it can balance the thing? So it can balance, right? So what's the smallest force? Well, it is still taking moment about O, right? The smallest force will only occur when F is 90 degrees to the line. Why? Well, just imagine if your force is not 90 degrees, let's say. So you, this is not D, right? So in order, it is the same logic. Okay. Definitely this is going down to 90. Alright? So moment, the counter moment to balance it is what? Defined as force times distance. To get the smallest force, moment is force times distance, right? To get the smallest force, D must be the largest. Agree? Yeah. So your F like that. This D, do you think is when is the largest D? Only when it's perpendicular. You understand? Anything beyond the 90 degree, let's say smaller than 90 here. This is the perpendicular distance. Can you see? You understand the logic? This is testing of concept and logic as well. those students who really can get it, those are the, what do you call that? Those are students who can do it, okay? So you understand this logic? You understand that only when it's 90 degrees, then D is the largest, so that your F is the smallest. That's all. So how do you equate? Very simple. Summation of moment must be 0 because you want to maintain equilibrium. So sum it up. This 90, you write 90 because it's positive. And this is positive, correct? And this is, you need to balance, right? So the force must be in that direction. So it's minus F times D equals to 0. D you can find. So F is equals to what? 90 divided by D. That's the answer. So that's concept. Yeah? Yeah? Okay, because you have not tried. You must try. Huh? Why the force is 90? This one? Why? No, I'm assuming the what? What do you mean? You must try lah. If you have not tried, of course you wouldn't understand what I'm trying to say, but the general idea is like that.
D is 1.75.
Which one? D?
Yeah.
D is 1.75. This distance is it?
Yeah.
You have this length, you have this length, you can use Pythagoras to get. Correct? Yeah. Okay, any question? No one? So, let's move on to the others question, so-called others. But it is not as hard as you think. Because when I cover this free body diagram, I told you a very systematic way to solve it, right? If you still can recall. Question 4 always tells you on free body, definitely, right? What is free body? You must be able to tell yourself. Free body is an analysis of forces, right? So you draw the body out first. Body can be just made of what? Lines and dots. Yeah? The question will definitely ask you to draw free body. See? Draw the free body of A, B, C. Huh? Yeah. So, free body, first thing, you must remember what are the 3 types of forces. External. Look at the problem. Any external forces? Yes. Where? Here and here. Correct? 3 and 2. Okay, that's settled. Any internal force? Sorry. There's no applied force. There's no external force. 3 and 2 is the one. Internal force. So it's Ng. Yeah? So last but not least, reaction force. How is the body supported? It is supported here and here. Analyze each support individually. So look at A. You must indicate X, Y, and moment. Reference frame. Can move in the X? Cannot, right? So R-A-X. Can move in the Y? No. R-A-Y. Look, settle, can rotate, so no reaction moment. Go to B. B is a ball. Can move in the X?
No.
No. So there must be a RBX. Yeah? Can move in the Y? Yes. Good. So this completes the free body diagram. You draw this with the respective numbers and alphabets. You get 2 marks. Yeah? Then next thing you know, definitely draw this for what? Cause to find the unknowns. Yeah? Correct. So you must already picture your steps ready. You draw free body diagram, there must be unknowns. Of course, the question is going to ask you, find me all the unknowns. And most of the time, or at all times, it will be 3 unknowns. Because why? You only learn 2D. So you only have 3 bullets in your pocket. What are the bullets? Next thing you will write that for the body to be in equilibrium, summation Fx must be 0, summation Fy must be 0, summation moment must be 0. By writing that, the marker know that you know your stuff.